this is your Kalpana here. So in this video we are going to see a problem from exponential series. Okay, problem: find the sum of the series 1 by 1 factorial plus 1 plus 2 by 2 factorial plus 1 plus 2 plus 3 by 3 factorial plus 1 plus 2 plus 3 plus 4 by 4 factorial plus so on. Okay, solution. So before going to the problem, let's see what is n factorial. So the formula of n factorial is 1 into 2 into 3 into so on n minus 2 into n minus 1 into n. Okay. So if we could write it as 1 into 2 into 3 into so on into n minus 2 into n minus 1 into n, you could write it as n minus 2 factorial into n minus 1 into n. Okay. Or if you are including n minus 1, then you could write it as n minus 1 factorial into n. Okay. Likewise, 1 factorial equals to 1, 2 factorial equals to 1 into 2, 3 factorial equals to 1 into 2 into 3. If you are getting n factorial equals 1 into 2 into so on into n, 1 will be 1, 2 factorial will be 1 into 2, that is 2 terms or 2 numbers. 3 factorial will be 3 numbers, 1 into 2 into 3, and 4 factorial will be 1 into 2 into 3 into 4. Okay, you'll get the same number at the end. Okay, okay, fine. Now coming to the problem. So we are given the series 1 by 1 factorial plus 1 plus 2 by 2 factorial plus 1 plus 2 plus 3 by 3 factorial and plus 1 plus 2 plus 3 plus 4 by 4 factorial plus so on. Okay. So here how many terms we are having? 1, 2, 3 and 4. Let us consider the first term as t1 equals to 1 by 1 factorial and second term as t2 equals to 1 plus 2 by 2 factorial t2 equals to 1 plus 2 by 2 factorial and t3 equals to 1 plus 2 plus 3 by 3 factorial. Likewise, we are having t4 equals to 1 plus 2 plus 3 plus 4 by 4 factorial. See, you're having first term 1 by 1 factorial and second term 1 plus 2 by 2 factorial and third term 1 plus 2 plus 3 by 3 factorial and fourth term 1 plus 2 plus 3 plus 4 by 4 factorial. Likewise, we can write for the nth term, right? The nth term could be Tn equals to, see, everything ends with the same number, okay, by the same number factorial. So what could be the nth term? 1 plus 2 plus 3 plus so on plus n. It should end with the same number by the same number factorial. That is, you'll get n factorial, right? So here we are having the nth term of the given series. The nth term of the given series is Tn equals to 1 plus 2 plus 3 plus so on plus n by n factorial. Okay. See, we have considered the first term as t1, second term as t2, third term as t3 and fourth term as t4. We know that since the sum of the first n natural numbers one plus 2 plus 3 plus 4 plus so on plus n equals to n into n plus 1 by 2. Okay. So in the term Tn, if we consider the numerator of the nth term, you're having the sum of n natural numbers. So you could replace it with n into n plus 1 by 2. So this equals to n into n plus 1 by 2 by n factorial. So you could write it as n into n plus 1 by 2 into n factorial. Right? So now we are having Tn equals to n into n plus 1 by 2 into n factorial. Okay. Fine. So in the numerator I'm having n. I want to cancel this n. So what I'm going to do is I'm going to write n factorial as, since we are having n factorial equals to 1 into 2 into 3 into so on n minus 2 into n minus 1 into n. Okay. So I could write it as 1 into 2 into 3 into so on into n minus 2 into n minus 1 into n. So I can write this as n minus 1 factorial. Okay, see, ending with same number into n. You're having n here, right? So now I can write n factorial as n minus 1 factorial into n. Okay. So this is equals to n into n plus 1 by 2 into this n factorial. Since n factorial can be written as n into n minus 1 factorial or n minus 1 factorial into n. Both are same. Okay. So I could write it as n minus 1 factorial into n. Okay. So I can cancel n. So now I'll get n plus 1 by 2 into n minus 1 factorial. Okay. See, if n factorial can be written as 1 into 2 into so on into n factorial, then what could be n minus 1 factorial? Obviously 1 into 2 into 3 into so on into n minus 1, right? So, using this, you have written 1 into 2 into 3 into so on into n minus 1 as n minus 1 factorial. Okay. We are just using the factorial, n factorial formula. Okay, fine. So now we are having n plus 1 by 2 into n minus 1 into factorial. N minus 1 factorial, I can say. So in the numerator, you are having n. But I want to write this n in terms of n minus 1. So how we can write n minus 1? But in the numerator, you are having plus 1. So how I can get plus 1 in the numerator here? See, here you're having plus 1, but here you're having minus 1. So what you have to add here to get plus 1? So if you add plus 2, obviously 2 minus 1 is plus 1. So which is similar, right? See, Similar in the sense, same. 2 minus 1 is plus 1. Okay. And also you have written in terms of n minus 1. Okay. Fine. So here now, like in the previous step, we have cancelled n by changing n factorial to n minus 1 into n. Likewise, here I want to cancel n minus 1. So that I can change this n minus 1 factorial, right? Since you're having n minus 1 factorial equals to 1 into 2 into 3 into so on into n minus 2 into n minus 1, right? So I could write it as 1 into 2 into 3 into so on into n minus 2 into n minus 1, and this is obviously n minus 2 factorial. Okay, see, ending with same number into n minus 1. So here you can replace n minus 1 factorial by n minus 2 factorial into n minus 1. So this equals to n minus 1 plus 2 by 2 into n minus 1 into n minus 2 factorial. Okay. So now you can consider it as one term and 2 as another term, since you are having plus here. So finally you are having two terms. So you can split the total fraction into two fractions, right? So you would write it as n minus 1 by 2 into n minus 1 into n minus 2 factorial plus 2 by 2 into n minus 1 into n minus 2 factorial. Okay. So you're having Tn equals to n minus 1 by 2 into n minus 1 into n minus 2 factorial plus 2 by 2 into n minus 1 into n minus 2 factorial. Okay. So now in this first term you're having n minus 1 in the numerator and in the denominator. So you can cancel it. So finally you'll get 1 by 2 into n minus 2 factorial. But in the second term, you don't have any n minus 1 in the numerator, but in the denominator you have written 2 minus 1, n minus 1 into n minus 2 factorial. So I think you can change it to n minus 1 factorial, since n minus 1 factorial is n minus 2 factorial into n minus 1, right? So here you're having n minus 1 into n minus 2 factorial, but in the numerator you don't have anything to cancel n minus 1. So for that purpose, what we are going to do? We're just going to change it again to n minus 1 factorial, since n minus 1 into n minus 2 factorial is n minus 1 factorial. Got it? So now you can cancel 2, 2. So finally you'll get 1 by 2 into n minus 2 factorial plus 1 by n minus 1 factorial for n greater than equals to 2. Okay. If n equals to 2, you'll get 2 minus 2, which is 0. 0 factorial is 1, and here 2 minus 1 is 1 factorial, which is also 1. Okay. If it is less than 2, what happens if it is less than 2? Say 1. 1 minus 2 is minus 1. So here you will get minus 1 factorial. So which is not applicable. So obviously you have to consider for n greater than equals to 2. So you're having Tn for n greater than or equal to 2. Okay. Let it be. So let us consider T2. Let's check whether we are getting T2, T3, T4 or not. Okay. So I'm going to consider T2 for n equals to 2. Okay. I should get the second one, the second term. Okay. So now substitute n equals to 2 here. I'll get 1 by 2 into 2 minus 2 factorial plus 1 by 2 minus 1 factorial, which is equals to 1 by 2 into 0 factorial plus 1 by 2 minus 1 is 1 factorial, since 0 factorial equals to 1 and 1 factorial equals to 1. So we'll get 1 by 2 plus 1. So 1 by 1 is obviously 1, okay? So you'll get here 1 by 1. 1 by 1 is 1. So you could write it as 1 plus 2 by 2, which is equals to 3 by 2. Okay. Now consider this second term, which we have named T2, right? So you're having 1 plus 2 by 2. And we know that 2 factorial equals to 1 into 2. 1 2s are 2. So 2 factorial is 2. So you get 1 plus 2, 3 by 2 factorial is 2. So this is correct. Tn equals to the two terms. Sum of these two terms is correct for n equals to 2. Okay. For n equals to 2. Fine. Now let's check for 3. For n equals to 3. T3 equals to 1 by 2 into 3 minus 2 factorial plus 1 by 3 minus 1 factorial. So this is equals to 1 by 2 into 3 minus 2 is 1 factorial plus 1 by 3 minus 2 is 2 factorial. So you'll get 1 by 2 plus 2 factorial is 1 into 2, which is equals to 2. Okay, so you'll get 2 by 2, which is equals to 1. Or half plus half is equals to 1, I can say, right? So now consider the term 3, T3. Third term in the given series, you are having 1 plus 2 plus 3 by 3 factorial. So 1 plus 2 is 3, 3 plus 3 is 6 by 3 factorial equals to 1 into 2 into 3. 1 2s are 2, 2 3s are 6. So you'll get 6. 6 by 6 is again 1. So obviously Tn is correct for n equals to 3. Okay. Likewise, let's check it for 4. T4 equals to 1 by 2 into, substitute n equals to 4, you'll get 4 minus 2 factorial plus 1 by 4 minus 1 factorial. So this is equals to 1 by 2 into 4 minus 2 is 2 factorial plus 1 by 4 minus 1 is 3 factorial. We know that 2 factorial equals to 2 and 3 factorial equals to 1 into 2 into 3. So 6. So this is equals to 1 by 2 into 2 plus 1 by 6. So which is equals to 1 by 4 plus 1 by 6. Now take the LCM of 4 and 6. You'll get 2 2s are 4, 4 3s are 12. So you'll get 3 plus 2, that is 5 by 12. Okay, remember 5 by 12. Now I'm going to consider the fourth term, which is given in the series. Okay, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10 by 4 factorial is equals to 1 into 2 into 3 into 4. 2 3s are 6, 6 4s 24. Okay, so I'll get 10 by 24. 2 5s are 2 12s are. So this equals to 5 by 12. Same. So Tn is correct for n equals to 4. Okay. Likewise, it will be correct for n greater than equals to 2. We can consider any number. Okay. For n greater than equals to 2, Tn holds. Fine. So now we are having Tn. So here what is our main motto? What we have to find here? We have to find the sum of series. T1 plus T2 plus T3 plus T4 plus T5 plus T6 and plus so on equals to some value, right? So this is for n greater than or equals to 2. So now we are going to find the sum of the series. Therefore, the sum of the given series is, so you're having T1 plus T2 for n equals to 2, Tn is applicable, right? Tn holds for n equals to 2 and you're having T3 obviously for n equals to 3, Tn holds, and T4 for n equals to 4, Tn holds. Just now we have seen all this. So we could write it as summation Tn, that is 1 by 2 into n minus 2 factorial plus 1 by n minus 1 factorial for n greater than equals to 2, that is for n equals to 2 to some infinity. Okay, hope you got the point. So here we are having the sum of the series T1, and from this we'll get T2, T3, T4, T5 and everything up to infinity. Since we have checked the Tn for n equals to 2, n equals to 3, n equals to 4, and we know that Tn holds for n greater than or equals to 2. Okay, if you want you can check it. Just substitute n equals to 2, you will get the second term. If you substitute n equals to 3, you will get the third term. And like that, you'll get T4, T5 and all. Okay. So now this equals to T1, which is 1 by 1 factorial. Since 1 factorial equals to 1, so you'll get 1 by 1, which is equals to 1 by 1 is 1. And equals to 1, 2 to infinity, 2 to infinity. N minus 2 factorial plus 1 by n minus 1 factorial. So this equals to 1 plus. So here instead of writing 1, so this equals to 1 plus summation n equals to 2 to infinity 1 by 2 into n minus 2 factorial plus summation n equals to 2 to infinity 1 by n minus 1 factorial. Okay. So this equals to 1 plus, so 1 by 2 is constant. I am taking it out of the summation. I'll get 1 by 2 into summation n equals to 2 to infinity into 1 by n minus 2 factorial plus summation n equals to 2 to infinity 1 by n minus 1 factorial. So I could write it as 1 by 2 into summation n equals to 2 to infinity into 1 by n minus 2 factorial plus 1 plus summation n equals to 2 to infinity 1 by n minus 1 factorial. Okay. So this equals to 1 by 2 into, now substitute n equals to 2 to infinity in this. So you'll get 1 by 2 minus 2 factorial plus, now put n equals to 3. 3 minus 2 factorial, now put n equals to 4. You'll get 1 by 4 minus 2 factorial and plus so on. Plus you're having this 1, right? Let it be 1 plus. Now substitute n equals to 2 here. So you'll get 1 by 2 minus 1 factorial plus 1 by 2 minus 2 factorial plus 1 by, okay, already you have substituted 2, right? So here you'll get 3. For n equals to 3, you'll get 3 minus 1. 3 minus 1 factorial. For n equals to 4, you'll get 4 minus 1 factorial plus so on. Okay. So this equals to 1 by 2 into 1 by 0 factorial plus 1 by 3 minus 2 is 1 factorial plus 1 by 4 minus 2, 2 factorial plus so on plus 1 plus 1 by 2 minus 1, 1 factorial plus 1 by 3 minus 1, 2 factorial plus 1 by 4 minus 1, 3 factorial and plus so on. Since you're having 1 by 1 factorial, so you could change it as 1 by 0 factorial. Okay, since we have n factorial equals to 1 and n minus 1 factorial into n. If n equals to 0, if n is greater than 0. See, if n equals to 0, 0 factorial is 1. If n is greater than 0, that is if n equals to 1, 1 minus 1 is 0 factorial, which is equals to 1 into 1, which is 1. Okay, so 0 factorial equals to 1 factorial equals to 1. So obviously you can write 1 as 1 by 0 factorial. 1 by 0 factorial equals to 1, which is also equals to 1 by 1 factorial. Okay. See, since we are having 1 by 1 factorial, for that purpose I have written this 1 as 1 by 0 factorial so that I can include this 1 by 0 factorial inside the bracket. Okay. So we can include 1 by 0 factorial inside the bracket. So this equals to 1 by 2 into 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus so on. Okay. So this equals to 1 by 2 into 1 by 0 factorial is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 1 by 0 factorial is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on. Since we have e power x equals to 1 plus x by 1 factorial plus x square by 2 factorial and plus so on. If x equals to 1, we get e or e power 1, which is equals to e power 1 equals to 1 plus x 1 by 1 factorial plus 1 by 2 factorial plus so on. See here you're having 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on, and here also you're having 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on. So you can replace these two by e. So I'll get 1 by 2 into e plus e. So I could write it as e by 2 plus e, which is equals to e plus 2e by 2. So e plus 2 is 3e by 2, which is equals to 3 by 2 into e. Or you can say 3e by 2. Okay. So therefore, the sum of the series 1 by 1 factorial plus 1 plus 2 by 2 factorial plus 1 plus 2 plus 3, okay, plus 3 by 3 factorial plus 1 plus 2 plus 3 plus 4 by 4 factorial plus so on equals to 3 by 2 into e. So this completes the problem. Okay, fine. So we have seen a problem in this video from exponential series. Hope you will understand. We'll see you in the next video. Until then, bye bye.